Good morning, students. In the last class, we discussed about the Kirchhoff rules. One is Kirchhoff current law and Kirchhoff voltage law, right? So, in Kirchhoff current law, the algebraic sum of the current at the junction of node is equals to the zero, and algebraic in Kirchhoff voltage law, the algebraic sum of IR product is equals to the algebraic sum of the EMFs which are present in the loop. Right, so the significance of the Kirchhoff current law is conservation of charges, and significance of the Kirchhoff voltage law is conservation of energy. So in the last class I mentioned the voltage or power, so change that one into the energy. That is the significance of the Kirchhoff voltage law. Right, so today we start with meter bridge. Sorry, not meter bridge, it is a Wheatstone bridge. Or because this one has Wheatstone network, so very important for 5 marks, right? So what is Wheatstone bridge, right? So Wheatstone bridge, it is a device of 4 resistance, right? So Wheatstone bridge or Wheatstone network is a device. It has a 4 resistance, and it is used to measure the unknown resistance in terms of the other 3 resistance, right? So that gives the definition of the Wheatstone bridge or Wheatstone network. So, right, what is Wheatstone bridge or Wheatstone network? It is a device of 4 resistance. It is a device of 4 resistance, right? So, and it is used to measure one resistance. It is used to measure one resistance in terms of other 3 resistance. Right, so very simple derivation we have and very important, right? So what is Wheatstone bridge or Wheatstone network? It is a device of 4 resistance. That means it consists of 4 resistance. So what is the purpose of the Wheatstone bridges? It is used to find one resistance in terms of the other 3 resistance, right? So the diagram for the Wheatstone bridge is in this form. The 4 resistance which are connected in the rhombus shape, so calling the resistance R1, R2, R3 and R4, right? So mentioning the points here A, B, C, D, right? So these are the nodes A, B, C and D are the nodes, right? So the diagonally opposite sections or nodes is connected to the external power supply. That means we are connecting the points A and C to the external source, that is battery. Right. So plus minus, and here the current which is flowing from the external source battery to the Wheatstone bridge, and another opposite junctions B and D. The points or junctions between B and D is connected with a galvanometer having the resistance Rg, right? So this one is the galvanometer G, and it has the resistance Rg, or simply we taken G as the resistance of the galvanometer, right? So when G is the galvanometer, right? So galvanometer is a device which detects the flow of current in the circuit, right? So it is a device which shows the deflection. If the current is flowing through this circuit, then it shows the deflection, right? So that is the galvanometer, right? So now the current which is flowing from the external source, that is from the battery at the junction A, from the Kirchhoff current law, the current divides, because here we have only one input current and here we have 2 branches which are dividing from the junction A, right? So taken those currents as I1 and I2, right? So applying Kirchhoff's current law. So in the short form, we write that one as KCL. So apply KCL at node A or at junction A, right? So we can write here the from the Kirchhoff current law, we states that the current which is entering at the junction is equals to the current which is leaving the junction, right? So from that we can write I is equals to I1 plus I2. Taken this one as equation 1, right? So now the current I which is flowing from junction A to junction B. So what is junction or node means? Two or more conductors which are meeting at one point. So that point we call as junction, right? So again B is a node. So here the three conductors are meeting at point B. So the current which is flowing in the arc AB is I1, right? So at this junction again we have the three conductors are meeting. So the current which is flowing through the galvanometer, we can take that one as Ig, right? So the current which is entering at the junction B will leave in the two arms. One is through the galvanometer and another is through the resistance R3, right? So again Kirchhoff current law is applied at the junction B, right? Applying KCL at node or at junction B, right? So I1 is equals to Ig, and here the current which is flowing through resistance R3 we taken that one as I3, right? So Ig plus I3, right? So I3 is the current which is flowing through the resistance R3 and Ig is the current which is flowing through the galvanometer, right? So we need I3, we can write I3 is equals to I1 minus Ig, right? That means the current which is flowing through the resistance R3 we can write that one as I1 minus Ig, right? So now if you observe here the current which is flowing from A through the resistance R2, the current is I2, right? So the current is flowing from A to D. In the same way, the current flowing from B to D through the galvanometer. Here, the two currents which are entering at the junction D, that means D node, we have the two currents which are entering, that is I2 and Ig, right? So the current which is leaving, that current is through the resistance R4, right? So again, if we apply KCL at node D, right? So if you apply the KCL at the node D, the two currents which are entering into the junction, only one current is leaving from the junction. So from the KCL we can write I2 plus Ig, that is equals to the current which is flowing through the resistance R4, we can take that one as I4, right? So that is I4. Right? So directly we can write I4 is equals to sum of the two currents I2 plus Ig. Right? So this current which is flowing through the resistance R4. So now here at the junction C, two currents which are entering, that is I3 plus I4, right? So I3 plus I4, I3 we have I1 minus Ig plus I4 we have I2 plus Ig. So Ij get cancelled, we get I1 plus I2, that is equals to the current I1. Right? So input current ಏನಾಗ್ತದೆ ನಮಗೆ ಇಲ್ಲಿ exit ಅಲ್ಲಿ ಕೂಡ current ಏನು ಬರ್ತಾ ಇದೆ same. So that is I1 plus I2 we taken here as I, the same current which is flowing from the junction C, that one is I, right? So now applying Kirchhoff voltage law for the loop or mesh A, B, D and A. So I am taking one loop A, B, D, A in the clockwise direction, and for the loop B, D, C, A, I will take this one as in anti-clockwise direction. So your wish, you can take in any direction or in any manner, right? Now apply Kirchhoff voltage law for the loop A, B, D, then A. So it starts from A, then to B, then to D, again A. So here G is the galvanometer. It has the resistance, that is RG, or we can directly take that one as G, right? So from the Kirchhoff voltage law, here we have the resistance R1, RG and R2, but no cells which are present in this loop, right? So now if we apply the Kirchhoff voltage law for this loop, so we get minus I1 R1. So minus, because the current which we are taken in the clockwise direction, in the same direction the current is flowing, hence the voltage drop across the R1 is minus, right? So that one already we discussed in our last class, right? So again the current direction is from B to D. We also taken the current direction in the same direction, that is from B to D. So there also we getting IG, then Rg, where Rg is the resistance of the galvanometer, right? So Rg is the galvanometer resistance, right? So next, from B to D, after that from D to A. So the current is flowing from A to D, but we are taken in the anti-clockwise direction. That means the current which is flowing from D to A, right? So D to A is positive because we are taken in the opposite direction. So that's why we write that one as I2 R2, right? So in this mesh we don't have any EMF, hence that is equals to 0. Right? So taking this one as equation 1, right? Now for the second loop, apply KVL for the loop B, D, C and then A. So it starts from B, D, C and again B. So this is one closed loop. I am applying Kirchhoff voltage law for that loop, right? So the current which is flowing in the same direction as we taken in the order. So hence we get minus Ig Rg, right? That is IR product, Ig into Rg. So again here in the same direction, minus, either we can take I4 into R4 or we directly take I2 plus Ig into R4, I2 plus Ig into R4, right? So here the current which is flowing from A to Z, but we are taken in the opposite direction. So hence that voltage drop we are getting positive value plus I1 minus Ig into the resistance R3, that is equals to 0. This one has equation 3 and here equation 4. Sorry. 2, 3, right? So now to balance this Wheatstone bridge, so in bridge namge balance agbeku andre the current which is flowing through the galvanometer is equals to 0, then only this bridge is balanced, right? So we are going to find the balanced Wheatstone bridge, the condition for the balanced Wheatstone bridge, right? So for that, balancing condition for the Wheatstone bridge, balancing condition for the Wheatstone bridge is the current flowing through the galvanometer is equals to 0. That means Ig is equals to 0. So ಈ bridge ನಮಗೆ balance ಆಗಬೇಕಂದ್ರೆ the current flowing through the arm BD is equals to 0. That means the current which is flowing through the galvanometer is equals to 0. So this is the condition for balancing of the Wheatstone bridge, right? So now substitute Ig is equals to 0 in equation 2 and equation 3, right? So if you observe here in equation 2, if the current Ig is equals to 0, then Ig into Rg becomes 0. Then we get minus I1 R1 plus I2 R2, that is equals to 0. Right? So now if we rearrange this value, I1 R1, that is equals to I2 R2. So I1 by I2, that is equals to R2 by R1. So calling this one as equation 4. Right? So when Ig is equals to 0, the equation 2 becomes I minus I1 R1 plus I2 R2, because the current which is flowing through the galvanometer is 0. Right? So in the same way, the current which is flowing through the galvanometer is 0, then equation 3 becomes so here Ig is there. Wherever Ig, we need to put that value as 0. So 0 into Rg is 0. So minus I2 plus 0. So I2 plus 0 is minus I2 R4 minus I2 R4. Right? So plus I1 minus 0 into R3. So I1 minus 0 is I1. I1 into R3 is plus I1 R3, that is equals to 0. Right? So substituting Ig is equals to 0 in equation 2 and 3. So 1, we get the equation 4, I1 by I2 is equals to R2 by R1. So here also we can replace I1 R3, that is equals to I2 R4. So I1 by I2, that is equals to R4 by R3. Right? So taken this one as equation 5. So comparing equation 4 and 5. So comparing equation 4 and equation 5. So in the LHS we have the ratio I1 by I2. So here also we have the ratio I1 by I2. So if in these two equations LHS are same, then automatically the RHS also same. R2 by R1, that is equals to R4 by R3. So this we can write R1 by R2, that is equals to R3 by R2. So this is the balanced condition of the Wheatstone bridge. So this gives what? The balanced condition for Wheatstone bridge. Right? So ಇದನ್ನ ನಾವು ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬೇಕಾದರೂ ಬರೀಬಹುದು. R1 by R2 is equals to R3 by R4, or R2 by R1 is equals to R4 by R3. That means the resistance R1 divided by R2, that is equals to R3 divided by R4. So this we will achieve only when the current through the galvanometer is 0. Right? So this is the condition for the Wheatstone bridge. When the bridge is balanced, when bridge is balanced means the current through the galvanometer is 0. Right? So very important innovation. So several times they ask this for 5 marks. Right? So here we are applying both Kirchhoff current law and Kirchhoff voltage law. Right? So idu your convenient, ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ತಗೊಂತೀವಿ ಅನ್ನೋದು ನಿಮಗೆ ಕನ್ವೀನಿಯಂಟ್. So either you can type in this direction anti-clockwise, both you can take anti-clockwise or both you can take clockwise. Right? So ಯಾವುದು ತಗೊಂಡು ಮಾಡೋದು ಕೂಡ ನಿಮಗೆ ಫೈನಲ್ the relation you get R1 by R2, that is equals to R3 by R4. Right? So here we have the 4 resistance R1, R2, R3, R4. So out of these 4 resistance, if we have the values of 3 resistance, then easily we can find the 4th resistance value. Right? So if R2 is unknown, we can find R2 is equals to R1 into R4 by R3, where R2 is unknown resistance. Right? So if we know the three values R1, R2, R4, you know, then we can find R3. R3 is equals to R1 by R2 into R4, right? So namge 4 resistance alli yavadadru 3 resistance namge gottilla andre fourth resistance we can find using this balanced condition, right? So if they mention the bridge is balanced, then the current flowing through the galvanometer is 0, and always the relation is R1 by R2 is equals to R3 by R4, or R1 by R3 is equals to R2 by R4. So ನೀವು ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬೇಕಾದ್ರೂ ಬರ್ಕೋಬಹುದು when the bridge is balanced, right? So when if we replace that, I already mentioned that galvanometer is also resistance, right? So initially it has some 100 ohm resistance, right? So we get the balanced condition R1 by R2 is equals to R3 by R4. So if we replace this galvanometer by some 500 ohm resistance, right? So e galvanometer na ತೆಗೆದುಬಿಟ್ಟು ಬೇರೆ galvanometer which having the other resistance, so resistance value ಜಾಸ್ತಿ ಇತ್ತು ಅಂದ್ರೂ ಕೂಡ ನಮಗೆ ಸೇಮ್ ಬರುತ್ತೆ. That means the balanced condition is independent of the galvanometer resistance. So ನಾವು galvanometer ಅಲ್ಲಿ 500 ಕೊಡಬಹುದು ಅಥವಾ 50,000 ohm galvanometer ಇಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಿದ್ರು ಕೂಡ ನಮಗೆ balanced condition ಏನಿರುತ್ತೆ ಸೇಮ್ ಇರುತ್ತೆ. That means the balanced condition is independent of the galvanometer resistance, right? So 1 marks ಕೇಳ್ತಾ ಇರ್ತಾರೆ. ಸೊ ಗ್ಯಾಲ್ವಾನೋಮೀಟರ್ ಅಲ್ಲಿ ವೇರಿ ಮಾಡಿದ್ರೆ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಕಂಡೀಷನ್ ಚೇಂಜ್ ಆಗುತ್ತಾ ಸೇಮ್ ಇರುತ್ತಾ ಅಂತ. ಸೊ ಗ್ಯಾಲ್ವಾನೋಮೀಟರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವೇರಿ ಮಾಡಿದ್ರೆ ನಮಗೆ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಕಂಡೀಷನ್ ಏನಿರುತ್ತೆ ರಿಮೈನ್ಸ್ ಸೇಮ್ ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್, ಸೊ ಇಲ್ಲಿ ನಾವು ಎಕ್ಸ್ಟರ್ನಲ್ ಸೋರ್ಸ್ ಗೆ ಅಪ್ಲೈ ಮಾಡಿದೀವಿ. ದಟ್ ಮೀನ್ಸ್ ವಿ ಆರ್ ಕನೆಕ್ಟೆಡ್ ದಿಸ್ Wheatstone bridge to some source, that is the battery, right? So ಇಲ್ಲಿ ನಾವು ಬ್ಯಾಟರಿ ಸೋರ್ಸ್ ನ ಕೂಡ ರೀಪ್ಲೇಸ್ ಮಾಡಿದ್ರೆ, so initially giving some 10 volt, right? We get the balanced condition. So if we replace this 10 volt some 50 volt, then this balanced condition will always remains the same. So ನಾವು ಇಲ್ಲಿ voltage ನ ವೇರಿ ಮಾಡಿದ್ರು ಕೂಡ ನಮಗೆ balanced condition ಏನಿರುತ್ತೆ remains same. That means balanced condition is independent of the source which we are applying to the bridge. So ಈ bridge ಗೆ ನಾವು ಏನು source ನ ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ, ಆ source ಅಲ್ಲಿ ಏನೇ ವೇರಿ ಮಾಡಿದ್ರು ಕೂಡ ನಮಗೆ balanced condition ಅಲ್ಲಿ ಯಾವುದೇ changes ಆಗಲ್ಲ. It remains as it is, right? So this is the second case, right? So now if we introduce the EMF, right? So EMF is nothing but cell. So if we connected this to the cell and also it has some internal resistance R. So ಇಲ್ಲಿ ನಮಗೆ ಒಂದು cell connect ಮಾಡಿದ್ರೆ in that cell also some internal resistance. So cell ಅಲ್ಲಿ ನಮಗೆ internal resistance ಇರುತ್ತೆ. So internal resistance ಇದ್ರೂ ಕೂಡ ನಮಗೆ there is no variation in the balanced condition. So it is independent of all the three terms. One is the resistance in the galvanometer, and second one is variation in the voltage, and if we connected the EMF with the internal resistance R, so all these three factors will not affect the balanced condition, right? So idu ನೆನಪಲ್ಲಿರಬೇಕು. So important derivation. So very easy steps is there. So in 5 marks ಗೆ ತುಂಬಾ ಸಲ ಕೇಳಿದ್ದಾರೆ, right? So main important starts with KVL at node A, right? So now in KVL at node A ದಲ್ಲಿ I is equals to I1 plus I2 mention ಮಾಡಿದ್ರೆ directly you can write Ig is the current which is flowing through the galvanometer. So ನೀವು ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಾದ್ರೂ ಕರೆಂಟ್ ತಗೋಬಹುದು ಅಥವಾ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಾದ್ರೂ Ig ತಗೋಬಹುದು. So ಇಲ್ಲಿ Ig ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ ನಮಗೆ I2 minus Ig ಆಗುತ್ತೆ, ಇಲ್ಲಿ I1 plus Ig ಆಗುತ್ತೆ, right? So in this direction if we take a, so ಇಲ್ಲಿ changes ಆಗುತ್ತೆ, ಬಟ್ ನಮಗೆ ಏನೇ changes ಆದ್ರೂ ಫೈನಲ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನು ಬರುತ್ತೆ ರಿಮೈನ್ಸ್ ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ ಇದನ್ನ ನೀವು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ನೀವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಬೇಕಾದ್ರೂ ಕರೆಂಟ್ ತಗೋಬಹುದು. ಸೊ ದಟ್ ಈಸ್ ಫ್ರಮ್ ದ ಲಾಸ್ ಆಫ್ ಕಿರ್ಚಾಫ್ ಕರೆಂಟ್ ಲಾ ಅಂಡ್ ಕಿರ್ಚಾಫ್ ವೋಲ್ಟೇಜ್ ಲಾ, ರೈಟ್? So ಇಲ್ಲಿ I2 minus Ig, that is the current which is flowing through the resistance R4. Here I1 plus Ig, that is the current which is flowing through R3. So ಇಲ್ಲಿ just signs ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, right? So ಇದು necessity ಇಲ್ಲ ಈ steps. So understanding purpose I explained this one. So directly you can write applying KVL for the loop. ಸೊ ಇದು ನಮಗೆ ಇಂಪಾರ್ಟೆಂಟ್. ನಾವು ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ತಗೊಳ್ತಾ ಇದೀವಿ ಅನ್ನೋದು ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಲೂಪ್ ಫ್ರಮ್ ಎ ಟು ಬಿ, ಬಿ ಟು ಡಿ, ದೆನ್ ಡಿ ಟು ಎ, ರೈಟ್. ಸೊ ಕರೆಂಟ್ ಫ್ಲೋ ತರ ಡೈರೆಕ್ಷನ್ ಮತ್ತೆ ನಾವು ತಗೊಂಡಿರೋ ಡೈರೆಕ್ಷನ್ ಎರಡು ಸೇಮ್ ಇತ್ತು ಅಂದ್ರೆ ವೋಲ್ಟೇಜ್ ಡ್ರಾಪ್ ಏನಿರುತ್ತೆ ನಮಗೆ ಮೈನಸ್ ಇರುತ್ತೆ. ವೋಲ್ಟೇಜ್ ಡ್ರಾಪ್ ಅಂದ್ರೆ ಐಆರ್ ಪ್ರಾಡಕ್ಟ್ ಕರೆಂಟ್ ಇಂಟು ರೆಸಿಸ್ಟೆನ್ಸ್, ರೈಟ್. ಸೊ ಆಪೋಸಿಟ್ ಇತ್ತು ಅಂದ್ರೆ ನೀವು ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು, ನಾವು ತಗೊಂಡಿರೋ ಡೈರೆಕ್ಷನ್ ಈ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂತ ತಗೊಂಡಿದೀವಿ, ಬಟ್ ಆಕ್ಚುಯಲ್ ಫ್ಲೋ ಆಗ್ತಿರೋ ಡೈರೆಕ್ಷನ್ ಆಪೋಸಿಟ್ ಇದೆ. ಸೊ ಅವಾಗ ಇಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಡ್ರಾಪ್ ಏನಿರುತ್ತೆ ನಮಗೆ ಪಾಸಿಟಿವ್ ಇರುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ ವಿ ಟೇಕನ್ ಪ್ಲಸ್ I2 R2. ಸೊ ಇಲ್ಲಿ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ನಾವು ತಗೊಂಡಿರೋದು ಇದೇ ಡೈರೆಕ್ಷನ್, ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರೋದು ಕೂಡ ಸೇಮ್ ಡೈರೆಕ್ಷನ್, ಹೆನ್ಸ್ ವಿ ಟೇಕನ್ ದಟ್ ಒನ್ ಆಸ್ ಮೈನಸ್ I1 R1, ರೈಟ್. ಸೊ ಇದು ಆಸ್ ಪರ್ NCERT ದಲ್ಲಿ. ಸೊ ಯುವರ್ ಕನ್ವೀನಿಯಂಟ್ ಗೆ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಫ್ಲೋ ಆಫ್ ಕರೆಂಟ್ ನಾವು ಪಾಸಿಟಿವ್ ಅಂತಾನೂ ತಗೋಬಹುದು, ರೈಟ್. ಸೊ ದಿಸ್ ಇಸ್, so in previous some textbooks they mention the current direction and your chosen the direction. If both of them we can take plus I1 R1. When the current direction and your chosen direction will opposite, so that case we can take minus, right. So now exam ಅಲ್ಲಿ NCERT book follow ಮಾಡ್ತಿರೋದ್ರಿಂದ ಆಪೋಸಿಟ್ ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ಪ್ಲಸ್ ಇರುತ್ತೆ, ಇನ್ ದ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇತ್ತು ಅಂದ್ರೆ ಮೈನಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಇದನ್ನ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ರೈಟ್. ಸೊ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ for 5 marks. And also if we vary the resistance in the galvanometer or if we vary the voltage across the Wheatstone bridge, right, or if we introduce the cell to the Wheatstone bridge, the balanced condition is remains same. That means balanced condition will not alter, right. So this is about the Wheatstone bridge. So Wheatstone bridge is the device of 4 resistance and it is used to measure one resistance in terms of other 3. So aduna ನಾವು ಇಲ್ಲಿ ಬರ್ತಿರೋದು. So I am going to measure the resistance R2. So R2 is unknown and R1, R3, R4 are known resistance. So I am measuring the resistance R2 in terms of other 3 resistance, right. So current directions ಮತ್ತೆ arrow marks ತುಂಬಾ important. So if you didn't mention any current direction, so derivation has no meaning. So in chapter ಅಲ್ಲಿ ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಕೇಳ್ತಾರೆ, ಜೊತೆಗೆ derivation ಕೂಡ ಇರೋದ್ರಿಂದ each and every derivations are very important. So next is meter bridge. Right. So what is meter bridge? So meter bridge is also a one device which is used to measure the unknown resistance or to compare the two unknown resistance with the known resistance. So that one we call as a meter bridge. So it works on the principle of the Wheatstone bridge. That is, from the balanced condition of the Wheatstone bridge, we are going to find the unknown resistance and also we can compare the unknown resistance with the known resistance, right. So meter bridge. So what is meter bridge? It is a device or instrument. So idu namage lab alli ide. So lab alli we are going to do 3 to 4 experiments on the meter bridge, right. It is a device which is used to measure the unknown resistance under the principle of Wheatstone bridge. So it works under the principle of the Wheatstone bridge. That means balancing condition. R1 by R2 is equals to R3 by R4. So our balanced condition use ಮಾಡಿಕೊಂಡು we are going to measure the unknown resistance. So lab ಅಲ್ಲಿ ಕೂಡ ಇರೋದ್ರಿಂದ ಸೊ ನಿಮಗೆ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ ಅಂಡ್ ಆಲ್ಸೋ ವೈವಾದಲ್ಲಿ ಕೂಡ ಕೇಳೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ, ರೈಟ್? So principle, on what principle the meter bridge works? So meter bridge works on the principle of the Wheatstone network or Wheatstone bridge, right? So Wheatstone bridge do balanced condition ಏನಿದೆ ಅಂದ್ರೆ R1 by R2 that is equals to R2 by R4 and it is independent of the resistance in the galvanometer and also EMF with an internal resistance and also the voltage which we are applying to the bridge, right? So in the name itself, meter, right? So meter and it is a bridge or network. We call that one as bridge or network, right? So meter bridge consists of one resistance wire of 1 meter length, uniform resistance. So meter bridge ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂದ್ರೆ ನಮಗೆ one uniform wire ಇರುತ್ತೆ. So the length of the uniform wire is 1 meter and it is clamped to the wooden board at the two ends, right? So A, B, calling this as A and B. The wire is connected between the points A and B is of uniform resistance. Uniform resistance means at each and every point of the wire the resistance remains same, right? So uniform wire of resistance of length is 1 meter, right? The length AB that is equals to 1 meter. Hence the name given as meter bridge. So now we will togondiro wire the length is 1 meter ide. Hence the bridge name given as meter bridge, right? So next, two L-shaped metal clamps or metal strips are clamped at the two ends of the wire, right? So this is L shape. So reverse L shape ಅಲ್ಲಿ ಇದೆ, right? So two L-shaped metal strips. So ಇವೆರಡು ಏನಿದೆ ನಮಗೆ metal strips ಇದೆ. So ಎರಡು ಸೇಮ್ ಸೈಜ್ ಅಲ್ಲೇ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ವೇರಿ ಆದರೂ ಕೂಡ two L-shaped metal strips which are connected at the two ends of the wire and it is mounted on a wooden bridge, right? So now in the gap between the two L-shaped metal strips, one more metal strip is mounted on the wooden bridge, right? So in gap between ali one more metal strip is clamped between the two L-shaped metal bridge, right? So here we have the points, right? So calling this one as E, F, D, L and M, right? So now this is a wire of uniform resistance having the length 1 meter. That means AB length is 1 meter and at the two ends of the wire we clamp the two L-shaped metal strips. So all these three are the metal strips, right? So now at the point A and B we connected to the external power source. So as this is works under the principle of the Wheatstone bridge, this arrangement is connected to the external source of battery voltage, that is B, right? So that is current I is flowing through the circuit or flowing through the bridge. So our aim is to measure the unknown resistance, right? So now aim is meter bridge use ಮಾಡಿಕೊಂಡು we are going to find the unknown resistance. So unknown resistance which we are going to measure is clamped between or connected between the two ends of the strips, that is metal strip ali between E and F ali we are going to connect one unknown resistance which we are going to measure, right? So that one we taken as x, where x is unknown resistance, right? So in the another gap between the two metal strips, we are going to connect with a standard resistance. So that means where S is a standard resistance, so this resistance is the known resistance. So namge S gotiro resistance, X is unknown resistance. So here we are going to measure the unknown resistance with the help of the known resistance, right? So where S is the standard resistance or known resistance, right? So now from the point D, it is connected to the galvanometer. One end of the galvanometer is connected to the point B, and the another end is connected to the slider. We call this one as slider, right? Or slider, key or slider, right? So one end is connected to the D point and another end is connected to the slider. So slider is used to slide on the resistance wire. So ಈ wire ಮೇಲೆ ನಾವು slide ಮಾಡೋದಕ್ಕೋಸ್ಕರ ಒಂದನ್ನ slider ಆಗಿ connect ಮಾಡಿದ್ವಿ, right? So the current which is flowing, so ಇದು ನಮಗೆ metal strip ಇರೋದ್ರಿಂದ current which is flowing through from A to E and then through the resistance X and then to F and to the point D and to the point L, again to the resistance S and M, again B, and again it comes to B, right? So this is a metal strip. So idu namge metal strip irodrinda, so it conducts the current through the resistance X and also through the resistance S, right? So this is worked on the principle of the Wheatstone bridge. So Wheatstone bridge alli work ಆಗ್ತಿರೋದ್ರಿಂದ, so the condition for the Wheatstone bridge is to the current which is flowing through the galvanometer is equals to 0. That means the balanced condition Ig is equals to 0. So how we achieve the balanced condition Ig is equal to 0 in the Wheatstone bridge is, so ಇಲ್ಲಿ ನಮಗೆ S is a known resistance. So it's some resistance value we connected between the points L and M. So ಇಲ್ಲಿ ನಮಗೆ ಒಂದು known resistance ನ connect ಮಾಡಿದ್ವಿ, where X is unknown resistance, right? So now to achieve the current which is flowing through the galvanometer, right? So here 1 meter scale is placed beside of the wire. So ಇಲ್ಲಿ 1 meter scale ನ ಏನು ಮಾಡಿದೀವಿ, ಕನೆಕ್ಟ್ ಮಾಡಿದೀವಿ, right? Right? So 1 meter scale irodrinda 0 is at the point nearer to A and 100 is at the point nearer to B. So it is a centimeter scale, right? So centimeter scale or meter scale. So 1 meter is nothing but 100 centimeter, right? So starts from 0, 1, 2, so up to it has the values 100, right? So this is a centimeter scale and 0 is always near to the A and 100 is near to the B point, right? So that means the unknown resistance is always placed at the left side of the bridge, right? So namge ಇಲ್ಲಿ two gaps ಇದೆ, one is left gap and another one is the right gap. So left gap ಅಲ್ಲಿ ನಾವು ಯಾವಾಗಲೂ unknown resistance ನ ಫಿಕ್ಸ್ ಮಾಡ್ತೀವಿ, right gap ಅಲ್ಲಿ known resistance ನ ಫಿಕ್ಸ್ ಮಾಡ್ತಾ ಇದೀವಿ, right? So to achieve the current which is flowing through the galvanometer is 0, that means we are going to slide the slider which is connected to the galvanometer. So ಈ resistance wire ಮೇಲೆ ನಾವು ಏನು ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ, ಸ್ಲೈಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾ ಇದೀವಿ. So ಎಲ್ಲಿವರೆಗೂ ಸ್ಲೈಡ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ the galvanometer which shows the zero deflection, right? So initially If we take this one as the galvanometer, right? So it has the value starts from 30 and here is the 0 and again here it is 30, right? So 20, 10, 10, 20 and 30. One needle is there, right? So when there is no power is supplied or no current is flows through this galvanometer, it shows the zero deflection, right? So here we are connected to the battery in the initial stage. It shows, so galvanometer slider on our left side of it, right? It shows the total deflections 30, that is towards the right side, right? So the same slider is placed into the right end, then it shows the deflection in the opposite direction. So ಅವಾಗ ಏನಿದೆ ನಾವು connect ಮಾಡಿರೋ circuit proper ಆಗಿದೆ ಅಂತ. That means opposite deflections in the galvanometer it shows, right? So opposite deflections ತೋರಿಸಿದೆ ಅಂತ the circuit we connected is proper, right? So now when we place the slider at the point A on the resistance wire, the resistance wire ಅಲ್ಲಿ near the point A place ಮಾಡಿದ್ರೆ ನಮಗೆ opposite deflection, that means we are placing the slider at the left side, we are getting the deflections at right side. So galvanometer deflections ಏನು ತೋರಿಸ್ತಾ ಇದೆ ನಮಗೆ 30 ತೋರಿಸ್ತಾ ಇದೆ, that means opposite. So ನಾವು left ಅಲ್ಲಿ slider ಇಟ್ರೆ right side ಅಲ್ಲಿ deflections ತೋರಿಸ್ತಾ ಇದೆ, but the current which is flowing through the galvanometer is 0, means this slider has to come to the 0 point, right? So this slider ಏನಾಗಬೇಕು ನಮಗೆ 0 ಬರಬೇಕು. So ಅದು ಯಾವಾಗ 0 ಬರುತ್ತೆ? When we move the slider on the resistance wire. So ಈ resistance wire ಮೇಲೆ ನಾವು slider move ಮಾಡ್ತಾ ಹೋದಾಗೆಲ್ಲ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ? It decreases the value. That means it decreases the deflection. So for a particular point somewhere here at point C, the deflection in the galvanometer is 0. So when we reach the point C, we get the deflection in the galvanometer is 0. So that means there is no flow of current through the circuit, that is current not flowing through the galvanometer, right? So that length is measured from the point A, that we taken as L. As it is a meter bridge, so the remaining length is 1 minus L, right? So as this is working under the principle of Wheatstone bridge, that is R1 by R2, that is equals to, so I will write that one, R1 by R2, that is equals to R3 by R4. This is the balance condition for the Wheatstone bridge. So same here, where X is the unknown resistance and the wire is also having the resistance, that is from A to C. So this is also resistance and the length which we are measured to get the balanced condition 0, that is also having resistance. So comparing this with the balanced bridge, we can write X divided by resistance AC, right? So this wire has total resistance, so up to L we are going to measure, so that one we written resistance AC, right? So that is equals to R3 is S divided by the resistance BC, right? So S divided by resistance BC, right? So we know resistance R, that is equals to rho L divided by A, where rho is the resistivity, L is the length of the wire and A is the area of cross section. So this wire is uniform length and uniform cross sectional area. So the resistance of length AC, RAC, that is equals to rho L divided by A, where L is the length of the AC, right? So in the same way, the resistance RBC, that is equals to, resistivity is same but length is 1 minus L divided by A, right? So this is from the formula resistance R is equals to rho L by A. So here we taken length as L and here we taken length as 1 minus L. Now substitute in this relation, right? So X divided by rho L by A, that is equals to S divided by rho 1 minus L by A, right? So in the LHS, rho by A get cancelled, so we get X by L, that is equals to S divided by 1 minus L. So here X is the unknown resistance which we are going to find, right? So that's why X is equals to S divided by or SL divided by 1 minus L. So this gives what? The formula to find the unknown resistance X, where L is the balancing length. We call L as balancing length, that is AC. So balanced condition means Ig is 0. Balancing length is nothing but when the deflection shows in the galvanometer is 0. So now ಎಷ್ಟು length ಅಲ್ಲಿ deflection 0 ಇರುತ್ತೋ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ balancing length, right? So where X is the unknown resistance, S is the known resistance, L is the balancing length and 1 minus L is also the balancing length, right? So ನಿಮ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಅಲ್ಲಿ ನೋಡಬೇಕಾದ್ರೆ ಇದು ಕ್ಲಿಯರ್ ಐಡಿಯಾಸ್ ಇರುತ್ತೆ. ಸೊ ಥಿಯರಿ ಪರ್ಪಸ್ ಗೆ ಆಸ್ ಆಫ್ ನೌ ಇಷ್ಟು ಓಕೆ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಫಾರ್ಮುಲಾ is x is equals to SL divided by 1 minus L and it is when this is in meters. So meter ಅಲ್ಲಿ ಇದ್ದಾಗ SL divided by 1 minus L. So if it is in centimeter, if we measure the length in centimeter, then x is equals to SL divided by 100 minus L. So this is in centimeter and it is in meter, right? So ಎರಡರಲ್ಲಿ ಯಾವ ಫಾರ್ಮುಲಾ ಬೇಕಾದರೂ ನಾವು represent ಮಾಡಬಹುದು, right? So in labs ಅಲ್ಲಿ we almost use SL divided by 100 minus L, right? So this is about the meter bridge and it works on the condition on the principle of the Wheatstone bridge, and the Wheatstone bridge principle is R1 by R2 is equals to R3 by R4, right? So idu namage important, where X is unknown resistance. So unknown resistance is always connected in the left gap and the known resistance is always connected to the right gap, right? So namage S value gotirutte, L value gotirutte, then easily we can get the 1 minus L, right? So iduna lab alli solve ಮಾಡಿದಾಗ ನಿಮಗೆ ಐಡಿಯಾ ಸಿಗುತ್ತೆ, right? So in the next class and we have remained the last topic, that is potentiometer. So that is also working on the principle of the Wheatstone bridge. So we will continue in our next class. Thank you.